So we are now start for our IC presentation. So, sir, my name is Sanket Mandi and my roll number is 4072. So I'm now start for my IC presentation. So welcome everyone. Today we are going to explore how distributed system keep track of the time casualty, especially looking in the peer-to-peer systems and vector clock algorithm, how it works in the world of where the application is increasingly decentralized and understand the exact sequence of events without a single central timekeeper is a fascinating challenge over the next few minutes. So we are actually seeing how overall uh, topic will go. So there are uh, peer-to-peer system, the basics. Before we get to the clocks, let's briefly define our environment. Unlike the traditional client server model, where all the traffic routes through the one central coordinator, peer-to-peer, P2P system is a fully decentralized. Every peer on the network acts as a both client and the server, sharing the resources directly with others. This brings the massive benefits like the scalability, fault tolerance. If one node goes down, the system will survive. But decentralized remove the single point failure, which leads to directly our the main challenge. So that's the pure benefits of peer-to-peer system. Then we can move forward for the next slide. So the challenge, the ordering of distributed events. The fundamental problem is the P2P, the network in that there is perfect synchronized global clock. If the peer one sends the message to the peer two, then the network delay happens. How we can prove which event for the another? The wall clock timestamps are the useless is that because of one computer clock might be the millisecond ahead from the another. That's the main problem of into the P2P. So we need to system that can be definitively say the event A consider event B. If event B and the event C just happened occurs at exact same times, then independently, which we can call the concurrent events. So these are some uh, uh, basic challenges in our critical systems. So we can move on to the next slide. So uh, the vector clock algorithm. So that's the main topic of our presentation. This is where the clock algorithm comes in. Instead of looking at time of day, each process keeps the vector and a list of counters with one slot every process in the system. The rule is beautifully simple. Everyone start at zero. When the process has a local event, it increments its own specific slots in the vector. When the sends the message, it attaches the data vector to the message, and then when the another process receives the message, it looks as incoming vector. Take the highest numbers for the each slot and between one vector and the received one, and finally increments its slots, and in that way the overall vector clock algorithm can manage all the vectors with the help of the vector clock algorithm. So we can go on next slide. So uh, here we see the example of ongoing the vector clock algorithm for the P1, P2, P3 are the processes. And here we have to see how each process can implement their vectors as they can move into the one-dimensional space, and whenever they bring message to someone else, then uh, the second element can be incremented, and in that way, the total count of uh, processes with respect to vector will aggregate maintained inside the vector, and it can play the role of our algorithm. So, next slide. the causality, application, and the conclusion. By comparing these, the final vectors, the system can simply detect the causality. If the number of vector A is less than or equal to the number of vector B, A is definitely happen because of B. That's the main key points of power vector initialization and tracking them into the system. Uh, with the vector having conflicting higher and lower numbers like the 200 and 110, and the system knows neither causes the others. Then, as a concurrent, this is exact logic where the powers model distributed databases, the prevent data conflicts, and the keeps replicated systems synchronized globally. The vector clock reduces the logical time, bringing absolute order of decentralized chaos. That's the main uh, uh, problem solving using the vector clock algorithm, and that's the oral presentation from my side. So, uh, keeping attention on my presentation. Thank you, everyone. So, uh, thanks.